Hi, this is Kirk Davis with CAMPS, and we're very happy to have you here today. Um, our topic is mistake proofing the manufacturing worker, which I think is is very interesting. But I would like to introduce Ben Marsh and Dr. Zia, who are pioneers and innovators and entrepreneurs in the space of Industry 4.0 for the manufacturing worker. And we're first of all we're so happy that there are members of camps and that they're contributing to the camps community, and so I want to thank all of you for being here today. So first of all, Dr. Zia, it's been a pleasure to get to know you, and you started, I think you joined camps even before your company got all the way up and going. I mean,
Yeah,
you're brand new, spanking new. But do you mind just kind of giving us some of your background?
yeah. I have I'm an electrical engineer by training. Spent a few years doing machine vision in Germany, and spent some time working on industrial IoT. The first implementations in early 2000s, working with automotive manufacturers in Germany, and then moved to the US. Spent some years at NEC Labs America in the Bay Area. NEC is this Japanese conglomerate. Most of my work there was with automotives, German automotive manufacturers. Moved from there up here to Redmond, Washington, to Microsoft, where I was leading a team inside of Microsoft HoloLens. So HoloLens is this head-mounted device that you literally put on your head, and you can see things on the display and help your work guide your workers through a complicated process. It has its own weaknesses, but it was a great experience. Got the chance to work with a lot of real frontline worker use cases in construction and in manufacturing, actually even in healthcare. But that's kind of where I'm coming from.
Well, I really appreciate that. In just a moment, we're going to have you share your video. But Ben, would you give us some of your background?
Yeah, absolutely. So, by formal training, I was a mechanical engineer with emphasis in mechatronics. As soon as I entered the professional career, I found manufacturing, fell in love with manufacturing, pursued my black belt in Lean Six Sigma, and I bounced around to multiple different factories, be it with employment opportunities or just visiting vendors and working with people on side projects. And throughout my career, I just discovered that there was an enormous gap between the informational world that we live in and the standard processes, the manual processes in manufacturing. And I always say that I'm always excited to talk next to somebody from the AI world, because I am an adamant believer that artificial intelligence is going to have a larger impact on manufacturing than automation ever has. And artificial intelligence will work only as good as the data that is collected. And so our process entirely is about how do we capture accurate data so we can then feed it to an AI engine and bridge that gap between the manual assembly world and then to this IoT world.
I really appreciate that, and I think again, both of you have two different approaches, but separately or apart, they're both, I think, going to revolutionize. Like you said, that's a really strong statement that AI will probably revolutionize manufacturing more than automation ever will. That's a very strong statement. So with that, Dr. Zia, if you wouldn't mind sharing your video, and I'll have you
Yeah.
share your PowerPoint after.
Oh yeah, sure.
Assembly on today's factory lines can be incredibly complex. Operators work tirelessly on these lines, yet customizations, fatigue, and inexperience lead to mistakes. Our retroactivity solution assists operators by pointing out any assembly mistakes they make in real time. Such local continuous quality control improves first-time yields by 10% and reduces quality issues by 60%. Our patent-pending computer vision technology understands complex human activities, as well as fine details of the parts being assembled. To set up retroactivity, one only needs to record a handful of video demonstrations and provide the bill of process. These demonstrations are used to learn a computational model of the activity, which is ready to deploy within a few hours. Additionally, our analytics dashboard is used by lean engineers to perform root cause analysis and continually improve processes. Talk to us to schedule a demo today, and we'll help you to make the most out of your assembly lines. Manual assembly
Sorry
on
about that.
today's factory.
Yeah.
No, thank you very much. So I think there's going to be a lot of questions about your video and your technology.
Sure.
But let's go ahead with Ben and have you share
Yeah.
your PowerPoint.
Certainly. All right, so get this going. All right, are you seeing the Scout Systems logo here?
Yep.
Perfect, thank you. All right, so what we try to do is to assist manufacturers to go from the old era to the modern era of the digital factory. So our approach is to focus on how do we implement technology with the minimal impact on manufacturers. And the way that we believe this is the most effective is to start on the production level, whereas traditional or old school MES and ERP platforms will have a lot of upfront work from the senior management team that has to broadcast down, this is the route, this is how things are supposed to work, and everything needs to be put up front. What we try to do is we try to put a platform on the ground level for your operators so that immediately upon using it, you're able to stream data to give you that information so you can make educated decisions. As you figure out these problems that you have and you begin to resolve them, you could choose to increase the sophistication at your own pace. And so some of our customers ask about, well, what does it look like when you have everything dialed in? And of course, this is a journey to get there. Some companies can move very quickly, but others it can take years to slowly implement these. So some of the things that we put is in a traditional assembly line, our system will be communicating with the ERP. So that way your production orders will come directly to your operators. No need for paper travelers, no need for having people add additional jobs into a schedule. You could have this sync between the two platforms to communicate. And then the operators, as they log in, we know the identity and location of each of your staff. So we can record where your operators are working to build cross-training matrices. So you can understand very well where your skill set's being invested. We do have a work instruction platform that can be used with or without instructions, but that's the portal to allow us to communicate with your operators directly and to be able to learn the tasks that they use. So if you're choosing to use the work instructions, you could put step-by-step, you could use videos, and it gives them a clean instruction of the bill of material, tools they need, and what they're supposed to do. The work instructions, we do have a piece of hardware that we call Tracker, and this can be integrated in with test equipment. So if you want to validate and make sure that your operators are using the correct equipment, if you want to track and measure OEE of your uptime of your equipment as well, they can be cross-related. And so if it's set up in a way as a gate check, operators will not be allowed to move forward unless a task has been done successfully. You could also integrate in tools. So if you wanted to validate and take measurements to make sure that certain inputs are correct, you could also do that as well. And then that's also a very good tool to use to make sure that operators aren't missing tactics. And then so a common one that people ask about is for traceability concerns. So for those that have a specific product that if you ever have a customer that claims a defect and you need to go back and to either double check your process or to maybe argument against that claim. So you could put in a serial number and our system will go back and see exactly where that product was touched, by whom, what stations. If there's test equipment validation, you can have all of that follow along with that serial number. A common one that people are doing also is they're using web cameras. So you can install a web camera at your station, and while the product is moving down the line naturally, our system will engage the camera, snap a picture, and then associate to that serial number as well. So if your customer claims that a critical component was overlooked or missed, you'll be able to go back in time to see all the content associated and verify that that in fact was placed. We do have a secondary application, which we call HQ. This is the headquarter. So Compass is what's used on the production floor. It's what's shown behind me here. And then HQ is for anybody that's in an office. You could see and adjust your schedule in live time. You have executive dashboards where you can review your KPIs, where your waste is, your live time OEE. We have an andon built in, so you don't have to go through and install all of the traditional lights. Instead, you can go completely digital, walk around with tablets and see exactly where your assets are and if they're down, for how long and why. The work instruction platform we designed to be very similar to a video game. So that way the next generation of staff that's entering the workforce, we want to make sure that they are trained, and they already are trained to use these video games. So why constantly try to teach them how to read an engineering print where we could put this in a native view that is very comfortable to them. And we have a large array of production reports to show you analysis of your production, where your operators are building, how much time is being consumed into what category. And then of course, for API integration, if you'd like to connect into an ERP, vision systems, test equipment, maintenance platforms, we swap data back and forth to make sure that your communication is all coming in live time, and it can be sent out and taken from all these components, so that way all of your intelligence can happen instantly without error. And then just quick viewpoint on this is moving into a digital factory seems to be a daunting project, but the reality of it is that the only upfront cost that you really have with a platform like this is the initial computer investment. For those that already have computers, this thing has an almost instant ROI. People see decreased defects, they see significant increases in capacity, WIP, they have better visibility of it, so they're able to consume it more quickly. And of course, all of the time studies, manual entry of data, all of that goes away. And instead, you can focus more on building your product and just cut out all the extra work. Go.
Okay, that's great. Thank you. Thank you for the presentation. So first of all, I'd like to just ask people in the audience, if you have questions, you can unmute and let the dialogue begin.
I had a question about the first system, Zison, is that saying your name correctly?
Yes, yes, ma'am.
We have systems internally that are picked to light, that walks the operator with instructions, and they need to push the light to advance. But once they get super trained on it, oftentimes it's hard to keep them motivated to continue to use the system because they're so familiar. For your system, is there anything inherent in it that makes it more than a passive instruction? When it says red, you've missed the fan, can they close up the e-box and pass it on?
Yeah, so we have seen that problem before, exactly that a lot of interactions, if the worker is needing to do a lot of interactions, telling the system that I've done step 1 and now I'm moving on to step 2, that can slow down processes, and that you are essentially asking the worker to change their behavior, to change fundamental human behavior. Mm-hmm. They're on the clock, they need to do this much today, right? And they're having to click a lot. So that's precisely what we are trying to address here. This is a solution that's in some sense passively sitting there, and it's looking at your workers, and we can have also projector based systems on smart workstations where we can provide mm-hmm. We can project digital worker instructions there, but there's this feedback component to our system that if you want it to run in the quality control mode, it only intervenes when the person is doing a mistake, right? If he or she forgot to do a step, that's when the system intervenes. So it's fine if they are well practiced, and if this is a very repetitive sort of a job, it's probably better that they don't have to interact a lot with the system, right? And if they miss a step, it's only then the system intervenes. So we have both modes, one where we can guide the person through the steps without requiring a lot of interaction from the person, and secondly where the system does complain that, hey, did you forget to put on the top bolt, or are you sure you're using the right screw at that location? Does that kind of answer your question?
Yeah, so it sounds like, though, if they chose to ignore the messages, say they forgot to put on a screw,
Right.
There's nothing that prevents them from moving forward if they just are completely offline doing it.
Yeah.
Unless you integrated maybe some clamps or something like that into the parts themselves that wouldn't let them move them forward, or set off an and-on light if they try to, something like that.
So certainly we do that. We can hook into existing lights, IoT lights, and mm-hmm. or we can even stop the line if there's if these are workers that are working on a conveyor system, we can literally just stop the line. But yeah.
Okay. Thank you.
Well, that's good. Thank you.
I had a couple of questions. I guess for both Ben and Dr. Zia, what I see is that it's static and it's in a regular assembly line. Are you looking at something in a more dynamic environment? And let's say I just used to work for a construction company where a project manager has a specific set of things that he needs to look at, and or you're looking at the contractor and you don't know the skill set of that contractor, that it goes through those same kind of steps. But I see the challenge here would be you've got a different set of plans, right? I mean, that's a challenge. So is that something that either one of you or in your software is looking at getting to in a dynamic way? And then I guess to Ben, on a separate question, I'm very big on AI. Not that I'm, trained formally on AI, but I see that the value going forward is, I mean, we're on the cusp, I think, of something that's going to have a huge impact on humanity, on everything. I mean, we're in the fourth industrial revolution of cyber revolution, as they say. So I'd be curious, Ben, as you look at, I saw your video and you say that you're helping organizations identify not just their current processes and how they can make them much leaner and much faster, but also in a way that, I'm sorry, my wife just walked in. When you're talking about improving up to automation, how are you doing that? Are you helping them understand what kind of equipment to put in to help automate their assembly line and improve even more of their output? So I guess there's a couple of questions. One is on the dynamics, and Ben specifically on the future of AI.
And Dr. Z, if you want to talk about the dynamics.
Sure, yeah. So definitely the initial use cases that we started out with were for basically just automotive manufacturers, right? And in automotive, often the whole assembly line, at Ford, the whole assembly line is moving. You have this large hull of a vehicle which is moving around, and workers, maybe it stops for a while, and workers put some parts on it. So we definitely can handle. We can track these moving pieces of on the line, but also on construction sites. Actually, that's very interesting, because at some point in time we were working with a Washington-based very large construction company, understanding what their workers were doing on a construction site, on an excavation site, really. I can also pitch in a little bit on the AI piece, right? The thing is, what we have seen is whenever there's a platform shift in technology, people start out with older ways of thinking, right? So when we move from newspapers to radio, the first radio programs were essentially reading news articles or reading dramas. There would be one person and reading something up, right? Or advertisements would be essentially just reading a piece of news article, an advertisement. And then when we moved from radio to TV, the same thing was happening. The earliest programs were essentially a couple of people sitting on a table, and just talking to each other, even when they were filming a drama. That's what we are seeing with a lot of the digital instruction use cases as well. That essentially we are just taking the paper piece of it and transferring it into, let's call it interactive PowerPoint presentations, right? And like Ben pointed out, right, if you really want to use, the real strength of digitization lies in feedback and in AI, and if the system can really look at, hey, did you do this step? Oh yes, you did, right? So that's the I completely agree with Ben that if you want to go to the key piece of digitization is the AI piece, right? That's where the real benefits lie. I don't know if that addresses it.
So Dr. Zia, I have a question real quick, and that goes back to something Bridget said, but that is, well, let's just say that your system wasn't necessarily disruptive to the worker, but it would send reports, to the management to say, it appears that these things were not done correctly. So there would be kind of a second level of oversight.
Yeah. So we do descriptive analytics as well as prescriptive analytics. We report cycle times, we report variations in individual steps, we report errors that are happening in, let's say, step 2, so that your industrial engineer can go in and figure out what went wrong. And something more in R&D is what we are working with NASA on is prescriptive analytics, where we can actually suggest The camera is looking at a process, and the camera can suggest, hey, maybe if you move the hammer from the top left corner of the desk to the bottom right corner, that will shave off 7 seconds from your cycle time, right? So,
Wow.
that's also something that we're working on.
That's kind of
But
shocking.
absolutely.
So, but I guess on a construction site, you have a set of plans, and when you talk about a large contractor, they may have multitudes of framing contractors, foundation contractors, finish contractors, etc. And so having a camera, looking at the framing or the foundation phase may be a little bit easier to be able to identify and help a subcontractor. Hey, look, you might want to, look at doing this better. I mean, unless those employees belong to you, then it's a little bit easier, right? Hey, look, do this, right? But we would have project managers that would go to the site and say, hey, look, these things have had to get done. And oh, by the way, have to be done to a standard to prepare us to get through the permitting or the inspection process, right? The quality control phase. And so when you have a multitude of plans, it's not like you can just have a camera set in a specific area on a job site, and then at some point you'd have to move it inside, and then it becomes, a challenge for the contractor to move around that. And I'm just using that as an example. On a commercial application, it's the same thing. So, and then of course you've got other issues, right? You've got Wi-Fi access. You might be building, in the middle of, Mount Everest base camp or something, right? So you don't have any Wi-Fi. So I think you probably have Wi-Fi in there now, but anyway, so does that get addressed in yours or Ben's application at all?
I could jump in on this one real quick. We do have customers that do servicing of naval ships, and so they have 490 different ships out there that they service. And for them, they build the components internally, then they ship them out, and then they're sending a tablet basically that is built in with our system. So that way, if the technician originally needed any assistance, historically, they would have to fly somebody out to the boat to make sure that they could take care of this. And then now, instead of that, they're able to build all their documentation, send it over to them to be able to give the tool access on that ship, and then they can get the analytics directly from them. In regards to the question about the dynamics of it, it's such a vague question to answer, but I can say that with every new customer that we set up, we do what we call onboarding, where we spend more time asking about the process of the customer than our system, because our system's quite versatile the way that it can be set up. So whether you have a moving assembly line, if you have moving operators, if you have static bench tops, all of these things can be addressed. The hardware component that we have, that's highly recommended to make sure that the operators are not engaging the software. By having the hardware in there, you can do the validations in live time and also automate all the clicking. So that way the operators, instead, they're using this as a tool because Dr. Z said it perfectly. You don't want to go from what we used to do, which was paperwork instructions that literally did nothing other than just hang in front of the operators. We need to make sure that the operators understand what they're looking at. We need to make sure that they are following those procedures. And why not take advantage of the data collection, the analysis, and then all the inputs that you could achieve to verify that your product is being built correctly and your equipment's also being used correctly. That could be used for maintenance and upkeep of everything that you have in your organization. But there's a lot that we can go into there, and I'm afraid there was one other question, but I might have missed it amongst the plethora of some of those. So if there's something
I did kind of forget that second part of the question that was addressed to you.
So I guess for Ben, in regards to, I watched your video yesterday, and it said that beyond what you're doing there for the desktop and the instructions, that you use your platform to help them understand how they could fully digitize and go more robotic in their organization. Can you talk a little bit about that?
Certainly. So now, something I take great pride in, as my introduction, I talked about Black Belt and Lean Six Sigma. So when we process all the data, every single bit of data that we take in, we analyze it. So we run statistics against it, try to figure out and validate how accurate is this data set. So when you run production reports within our system, it will cut out the noise, something that an engineer should do with a bulk array of data. Instead, we just go through it and we trim it and we give you the correct results. In our system, it will map out your work area and it will show your instruction sets with your estimated cycle times of each of those. You could zoom into it further so you could do task oriented, as opposed to knowing the cycle time is 2 minutes plus or minus 15 seconds. We'll show you that each subtask is 15 seconds, 30 seconds with these deviations. And that's extremely powerful. When you're trying to figure out ways to trim down your labor to be able to optimize your route, the best opportunity is to find your widest standard deviation, because that's usually your low-hanging fruit. If it takes one person 40 seconds and somebody else it takes a minute and a half, why is there so much variation in your organization? So our goal is to highlight those elements. Within avoiding some of the real technicalities of it is, as the system gets built up, we recognize different family classes in it. And so our customers also use this to figure out better routes, to figure out which stations are more capable. And we're constantly adding to our platform, but our end goal is to be able to optimize the route from the very first origin of your plant to your exit location, to be able to recommend that this station would be more efficient with this product, knowing the individual capabilities of each of your operators. We want to be able to tell you that these operators, if you put them in this line, you'll get a 10% yield higher. So that way, if you have a rush day, rather than just telling your operators, we need to go faster, we need to go faster, we want to be able to strategically give you better insight to that. And if you have a slow day, in the reverse, maybe you should cross-train a little bit more, slow down your operations, but these operators, there's a vacuum of knowledge that we are looking to fill. So much of this can be done, and then there's always room to grow, and that's what we're trying to do.
Thank you.
Of course.
So when you think about your own operations, Gary, I see Gary Moe here. It's nice of you to join us, and appreciate you taking part of this. And Allison, I'm wondering what kind of things are on your mind.
Yeah, I guess for me, I'm thinking through the how to square the old school concepts that are really low in cost and investment versus, you know, the new school concepts, and just pairing those with artificial intelligence. Bridget mentioned something earlier about, you know, in some cases an operator could still move on, and the old school concept of poke-yoke is to make it so that you can't, right? So just my mind is whirling thinking through that sort of situation.
I appreciate that. Ben and Dr. Zay, I'm sure you guys have had some experience with implementations and watching that adjustment.
Yeah, so poka-yoke systems is something that we claim our system to be a visual poka-yoke system, but like Bridget pointed out, it is a real weakness in the sense that we can't physically restrain the operator, right? Like you would in the case of limit switches or you know, make it just something that's unavoidable, like, I don't know, color coding of wires such that they put the right wires together. So we aren't quite at the, you know, poka-yoke level that we would be able to enforce something. We can still integrate with other solutions that allow us to, but yeah, that is certainly something that we could, you know, yeah.
The signal that indicates wrong, you missed a step, can that be, is that, could be used to, you know, like I was saying, clamp down the unit so they can't pull it out, or something? It's strong, it's the right kind of signal.
Yes, we can. Yeah,
okay.
that's definitely doable.
So in the Scout perspective from this one, so within our application, we do have what we call operator inputs or validation. This could be an electrical input, and this could be a manual entry. So in the perfect world, you are, again, this is the further down the line of sophistication. I do recommend taking baby steps to make sure that this is not an enormous elephant to chew down. So what I normally recommend is you slowly work this out. But so again, fasting forward to the fully dialed in, is if you had the sensory devices in place to make sure that these operations cannot be avoided, you could input that inside of your instruction tool. So you could say that on this step, it is absolutely vital that this has to be done. There's no exceptions around it. And our system will prevent the operators from being able to move forward. If you have smart tools and you have that embedded into our platform, we're working with all the major smart tool vendors so that we can actually turn their tools on and off. And we're looking into other programs as well. So that way we can go beyond just the fasting devices. Our hardware, we're working on an expansion board right now with an output, which is going to be used intentionally for a maintenance lockout. The biggest concern I have when it comes to physically controlling a process is always the safety liability. We have to make assumptions that your operators are following these processes as good as they possibly can. So for us to send out an electrical signal that can lock out a machine or to shut power down, we would need to make sure that that's done in a way that it can't cause any physical harm. So there are certain steps that you want to make sure that you avoid as you approach that. But what the best way that, in my opinion, would be is to make sure that as you're building out jigs and fixtures, you do put capabilities of using a limit switch. So that way, if the product is not fully seated, then there is no good signal from the unit itself. So the operators would not be allowed to move forward. And within our system, if the operators are constantly trying to break it or go against it, they're going to be prevented from moving forward. So our only form right now of doing poke-yoke is if you implement these gate checks, we will stop them and we won't allow them to move forward. And then if the leader supervisor is walking by, it is going to be very clear on their screen that the operators are not following the processes, because it is automated and it should walk them through it. So if it's not lining up, then you have a bad apple inside your assembly process.
Now, this brought up a lot of things from our previous conversations, but one of them is we're not really trying to use this to punish operators, right? So could you share, maybe both of you, your philosophy on how this isn't just a big brother thing?
Okay, I'll go first on this one.
There, yeah.
Yeah, so my background was in manufacturing engineering, and the operators, in my experience, know so much more than almost every single person in operations and engineering. If I ever knew that there was a problem on the floor, the first people that I speak to are always the operators. So whenever we do installations like this, I like to go to them and explain to them that you know more than the people that hired me to come here. And so my goal is not to listen to them and tell you what to do. Instead, my goal is to listen to you and figure out how do we configure the system so that way we can give a voice to you that's going to be heard with dollars and cents by your senior management team. I did it previously in a camp's presentation where there was a story that I was told by an operator, and he explained that there's a fish tank and there's a glass in the middle. One side is feeder fish, the other side's a predator. And he said that the predator constantly hits that glass trying to eat the prey fish until they pull the glass out once the fish stops trying to attack, and then it just swims cohesively with the group until the predator fish, of course, withers and dies because it just gave up trying to eat those feeder fish. And the operator tells me the story and explains that senior management is the glass wall and all those feeder fish are the problems. And the operators constantly are saying, this is a problem, this is a problem, this is a problem. And when it falls on deaf ears, they finally just give up and they stop asking for help. That is something that we have to eliminate entirely from every single process in order to advance. So within our application, we created a pause or a production stop. It's not just like an and-on where it goes red light, lines down. Instead, it has a custom configurable reasons for pause. And these are reasons that we like to get from the operators. And so one quick example was one of our customers, they developed very large piece of equipment. Every single order required a forklift or a crane. The operators could not pick it up. Operators constantly complained to their management team that we needed more forklifts in order to move this material. Management never saw it as a justifiable expense. So the first month that we were there, we made sure that there was a button for waiting for a forklift or waiting for a crane. And the management within 1 month saw how much time this was a frequent problem, and they bought the equipment that the operators have been demanding. That immediately starts to get that buy-in from the operators, and they see that as this is not a big brother that's penalizing me. This is a big brother that is seeing all the problems. And the honest reality is most of the problems are done by the senior management team because they just ignored something that's gotten bigger and bigger and bigger. And our goal is to figure out how do we put that into a ledger so that way the management can see how much is this costing us and how much could a solution help us avoid that cost. And the operators, they see it then as a tool that they typically enjoy.
So I have a follow-on question to that. So you could have a process that, builds a hammer, and you can follow the process to the T on how each of those tasks are to be done. And you can build 100 hammers, but 99 of them come back, then you know that there's something wrong. It's either the process or the product or the material that's being used. So in either one of your applications, is there anything that allows for it to have some kind of input or output to the leadership that says, hey, look, you got 100 hammers that are being built every day to the standard, but 99 of them being sent back. You need to change this in the process, or you need to go get better material or a different type of material. Does either one of your systems do that?
I'm sorry, Dr. Z, if I'm jumping
No,
over.
Ben, please go on. Go ahead.
Okay, so within our application, what we do is instead of a top-level bill of material, we focus on a task-level bill of material. And this, I swear, is going to answer some of your question here. The reason why we do it this way is we want to find out specifically where did that material get consumed. So there's specific data metrics that we analyze from a step-by-step process. Of that is where were the materials touched and how long were they being handled by the operator. So the interest that we have is that if you have defects, you'll be able to go back to the instruction tool where you'll see a change log. Why did things get changed? Who changed it? Who approved it? So at least we could see very clearly, this is the process that you put forth. So then when you have a defect, and if you say that this defect with your hammer example, maybe it's when you, maybe you had to anneal the steel. And so if that's where you determine that that is where the cause of your defect took place, we give you the ability to zoom into that very specific application and give you the data surrounding that. So what our goal would be is to find out, is there trends? Is it when the annealing is maybe on the lower half of the lower limit of your statistical confidence, or is it on the upper? So that way your quality team is basically capturing that SPC data where they can start to determine, for this step, we need to slow the operators down because we've found higher quality if it takes a little bit longer. So the goal is to give you that transparency so that your quality team isn't taking guesses, but instead they've been able to at least hone in on the issue. This is not 100% fix, but the goal here is to make sure that we give your people an educated guess of where they need to look so that way they can invest their time far more effectively.
Yeah. The big brother question is a very important one, and we are still trying to learn and reflect, and we've talked with folks at UAW, the Union of Auto Workers, to figure out what their stance on some of these things is. By default, they don't, basically UAW just doesn't allow any kind of cameras looking at humans in any of their factories. So we are trying to learn there. In our conversations, we have found that actually manufacturing workers are still surprisingly supportive of a system that's assistive, that can help with things like ergonomics, right? That can, at the end of the day, these workers are working very, very hard, right? So the one part of it is that the system is able to record that yes, they are working hard, right? And in that sense, that's useful to them as well. And to bypass some of the big brother like issues, we have looked into privacy preserving technologies so that your photo isn't stored, right? There is some anonymizing technology in there, or some anonymizing technique that basically doesn't allow the management to see individual things at the level of individual workers. They're only looking at things at the level of analytics, but sure, there is this pushback from the management that they'd rather they do want to see that at that granular level what's happening at each station. So it's something that we are learning as well. I don't really have a great answer, unfortunately, at the moment, but there are things around privacy, there are things around analytics that yes, we help the individual worker, but what we provide to management is more anonymized analytics at a broader level rather than at individual workstation level. But certainly the big brother piece of it is definitely something that we care a lot about, and we are still trying to learn on that, and would love your thoughts as well. Yeah.
Thank you.
I might want to add one more concept on this one is when it comes to the metric that you're talking about too, for figuring out how to boost the effectiveness of your operations, I think the best metric to use would be your OEE, or your overall equipment effectiveness. And in my opinion, that can be applied both to manual assembly as well as to equipment. Because if you are seeing that 99 of your 100 are all failed, then your quality score on that one is going to be just terrible, and it's going to wreck your OEE metrics. And just in case anybody's watching that is not familiar with this terminology, you take the percentage of good parts or your first pass yield, you multiply that percentage by your performance, which is your realized production speed versus your your ideal performance speed, and then you multiply that by your availability. How much time are we producing parts versus how much time was allocated to producing? So your quality times performance times your availability will give you your overall effectiveness, and that's your true capacity. So we do monitor that in live time, and one of the things that I think is really key about this is traditionally OEE has been a lot of data entry. You have to go out there with the time study and make assumptions of the highest performance is going to be X. What we do instead is we analyze, I believe it's the past 100 days, and we look for rolling averages so that way we can calculate out those performance keys. So as you're building out product using our system, the OEE is going to be continuously monitored and measured, and with the dashboards, your supervisors can see that. You could also run production reports if you want to do comparison. So ultimately, if you're using any type of data system like this, rather than rely historically on static data sets, with a dynamic live stream of this, you'll be able to constantly measure your OEE and see if you are improving your process. So as you do a lean event or a Kaizen event, if your OEE slips, then that event might not be as good as what you hoped it to be. And if your OEE is constantly improving, then that's showing you that your company is evolving with the times.
Wow,
Thank
that's
you, Ben.
good. Now, just a quick question here about, you know, are people, from what you've seen in your applications, I mean, is it really the workers that tend to be the problem, or is it the processes, the work instructions? Where do you see most of the pain points? Dr. Zia, go ahead. How's your experience?
Yeah. One piece of the pain points we are seeing are around you know, experienced workers retiring, customizations. So again, I was on a call with somebody in the morning, and they were talking about how they implemented this smart tables using a few off-the-shelf technologies for 7 different variants of the product that they produced. And now they're faced with a product where they have to put in fuses at very different locations and so on. And it's like, the number of products that they could conceivably build on that is greater than the number of stars in this galaxy or something like that, right? So it was somebody who was a mathematician turned engineer. But how do you address that? So customizations is something that's at the top of our list. Trying to incorporate expert knowledge is something else that we somehow want to computerize expert knowledge for training use cases, for quality control use cases. The temporary workers, it's another issue, again partly handled with better training, but still, if you are if your worker turnaround is also, turnover is also very high, then you have to have checks and balances in place that will make sure that this teenager or high school grad that's coming in is going to be effective at her job, right?
Well,
So,
and I think for both of your technologies, Dr. Zia, for both you and Ben, both of them accelerate the learning curve. And I think this is a very exciting part of what you both do is really upskilling somebody very quickly.
Yeah, and on that, the second question, or the previous one as well,
Yeah.
I think a common problem is that manufacturers that have not yet become digital, they grossly underestimate the problems that they actually have. I've gone into these companies where they assumed that their OEE was above 70%, but the reality of it is, as they start to get the correct data in there, that they will be almost half of that. There's problems that happen on a daily basis. Your operators, they might have a short production order, and they might intentionally slow down because they know they're going to finish early, and there's really no point. So there's things that will take place that just get completely overlooked. So that is one problem, but I don't like to point at an operator and say that they are at all the culprit. I would say that your capacity planning is probably incorrect, because if your ERP is forecasting your schedule based off of your demand and it thinks that this is how much time it's going to take, those numbers are going to be doing all of your logistical computing, and they are going to be naturally flawed. That's an enormous problem. Another common one is WIP. And the paper world leads to a lot of Peter taking from Paul. people are constantly trying to find materials. They'll run short, so they will do a rush order. They'll all go upstream to ask somebody to make them a new part because they lost it. And now they start to have inventory piling up, and there's no visibility of this. So we like to make sure that companies, they take a step back and they look at their entire operation. And something I say is that if you are not willing to accept the reality that your administrative work is going to be impacted by IoT, then you might not be fully ready for it yet, because there are going to be policy changes that you're going to need to change. Because as you have them in right now, it solved the previous era, but we're moving into this digital era where a lot of these things that you're doing are redundant, or they're just inherently flawed by the manual data entry sets of it. But there's a lot of problems. Tribal knowledge is huge. The manufacturing average age is still getting older. So we got an enormous amount of brain drain that is constantly leaving this industry, and we need to figure out how do we replenish it. On top of that, the manufacturing has not done a good job appealing to the younger generation. If you have the choice of working for a manufacturer or working for somewhere else that might be a little bit easier, the generation might choose to go the easier route. So what we're trying to help manufacturers do is, when you do get an operator, we're finding that operators tend to like to move around more. They don't like to build the same product 40 hours a week. So by cross-training your operators, it will boost their morale. And by having a system in place that can help teach them, our customers are saying that they're seeing a 50 to 60% reduction in training time. So now you can move your operators around, keep them fresh, keep them cross-trained, spread your tribal knowledge, and then increase your morale. Those are all wins. So there's a lot of problems that you could solve. But I would just say that I think most companies just grossly underestimate the problems they currently have.
I will actually mirror what Ben just said. We also had the same experience. We were working with some industrial engineering interns, and actually we went into very large factory floors, and again exactly. So some of the people we were talking to were grossly underestimating first-time yields, OEEs, right? And when we actually sat down, we spent a lot of time actually measuring those. Just sitting down with stopwatches, just counting things ourselves. We had exactly the same experience. So yeah,
Right.
the amount, yeah, there is a real need for the analytics piece in there as well, apart from all the other problems that Ben pointed out. Yeah, absolutely.
Yeah, I'm glad you see the same thing too, because it's a common problem that everywhere I go, it's the same story. Something also I would recommend too is if we rewind way back to when the internet first came about, when businesses relied on paper and fax machines and phone calls. So if you went back in time and you had somebody talking about the benefits of email, the benefits of the internet, there was a lot of people that would say, I don't know, we got a process in place, we got our equipment in place, what good is this going to do? They could not see what was going to come from it. The online accounting, the online ERPs, the online syncing with your bank accounts, everything got radically easier. And it's the same thing right now, is that when you're taking your operations from a historical method and you're moving it into a digital era, it is the same thing as the business world accepting the internet and then discovering the benefits from it. So another common problem that a lot of manufacturers do not that they have is the fact that they do not necessarily see the world that they could have, and they're blind to all the benefits.
Yeah.
Yeah, I was talking to somebody at this company called Xometry, XO, like geometry, but with X, Xometry. There's this manufacturing as a service platform trying to just take over the entire machining industry, right? And they've just put in this one piece there that's automated, which is they take in CAD models from you, press a button, and they can give you quotes right away, right? They've just automated the quotation process. Okay, you want to build this metal part, 50 units of 50 pieces of this is how much it's going to cost, right? And as opposed to smaller machine shops which take 2 weeks to get back to you, and they are basically just eating away a lot of these even larger machine shops. And absolutely, so there are a lot of things that are they're going to be this whole manufacturing as a service industry that's coming up, that aims to just eat away a lot of manufacturers essentially, right? And then the only way to combat those is through digitization essentially. So a lot of mini Amazons, if you will, opening up in the manufacturing space that are just absolutely. So I completely agree with Ben on that as well.
Could I just comment on that, Dr. Z? So, and I think both of you have said this, but digitization really is our defense against these new innovations and maybe companies in other countries that are preparing to eat our lunch, so to speak. So one of your, I think, offensive strategies really would be the digitization of your plant.
I was just on a call yesterday, and the customer was asking me where our business model is basically, and I was telling him that I'm disappointed to say that we are growing more in other countries than we are in the United States. When I go down to Mexico, or when I used to go down to Mexico, COVID permitting, that every customer, it was as if they rolled out a red carpet just because they know that the data analytics company is here. And to this day, when I go into manufacturers in the United States, there's a little bit of an upfront battle that I have to first explain that this is how digital works. This is why you want to go digital. When I go and talk to other countries, there is none of that. It is how fast can we get this up and running? What's your scaling rates? And they're full speed because they recognize that this is having profound impacts. And when the United States is still hesitant and they look down the street and they see a similar competitor or down the street from them and they look at them as their competitor, that's incorrect. The competitor, it could be across the pond for easy numbers, like just as Dr. Z was explaining, if they're taking advantage of all of the automation, they're able to cut out a tremendous amount of their administrative expenses. So not only is their labor probably cheaper because they're in a cheaper location, they're cutting down their administrative expenses, which is going to have a significant decrease in their overall cost. So even if we're putting tariffs on products that are coming in here, these countries are going to still be able to outperform us. And this technology is all available to us right now. And the ROI on this technology is so quick. It's not like a robot. It's not like buying a fiber optic laser that's going to cost you $1 million. We're talking about a minor investment that can increase your overall capacity by 10+%. Whereas if you buy a robot to do a job, you're going to spend 100,000 plus, and you're going to boost one cell by 25, 50%, which is great. But to lift your entire organization by 10% or to reduce your administrative costs by 10%, that's going to have such a bigger effect on your P&L statements. And that's something that we still as a country have not yet absorbed. And it's something that we need to wake up and move on quickly because other countries are doing it.
Yeah, actually, another anecdote on that, we were having a lot of trouble raising VC funding from Silicon Valley, but then we started talking to investors in Asia, and we got a check on our first call from a large investor in Vietnam, and another very significant check from investors in Japan, and then we reached out to some folks we were introduced to some folks in China. And there were a lot of offers from Czech until we got this grant from NASA, which prohibits us exclusively from. So the only thing that they ask us is not to work with China. So that's why we had to turn some of that money down. But it's very interesting that when I talk to VCs in Silicon Valley, they're talking about dating apps and sales sales enablement solutions and so on. But very little attention still being paid to manufacturing automation or industry 4.0 or enabling manufacturers. And some of the reason is precisely because those investors are talking to manufacturers there, right? So the Vietnamese investor that was able to put money into us on very, very favorable terms to us was he knows what's going on in Vietnamese. They are basically chasing all of these supply chain disruptions that are happening in China now, and yeah, it was a very interesting experience for us as well, I would say.
Goodness.
Okay. I'm enjoying this part of this conversation a lot. So the back and forth about where this technology is going about, a side question just to help also to envision what this will do for manufacturing is when I feel like we take a look back 10, 15 years about all the civilian applications that we can have. Specifically, I like to think about Waze, the GPS app for your cell phone. Waze is getting input data from everybody else that's using that. It's getting notifications where there's speed traps, where there's construction, where there's cops. It knows all of this because there's a network of devices that are communicating and sending it back. And the benefit to this is that in a live drive, you will get route updates, and it will tell you to a minute how much faster you're going to go from this one. And I use this a lot. And I always, when I get bored on long commutes, I like to challenge it, and I like to see how accurate is this data going to be. So I like to bookmark it and then just drive home and find out, did I get home at the same time or how much deviation? And I'm always quite impressed how accurate it is. So if we were to take that same type of technology and you applied it to a manufacturing facility, and think of it the exact same way, you have roads down your lines, you have different cells, you have different locations, you have different people, you have different problems, you have material shortages here, you have a down machine there. All of these are road construction products, cops, and all these other things that could interrupt your commute. And these devices can basically help show you, this is the way that you should run it through your route. And so if you could believe that Waze and GPS items are going to be able to have an impact on your commute, take that same technology and move it to your factory. When I talk to manufacturers in the United States, they often will brag that they have a barcode scanner in place and they're looking into RFIDs, which is great. You should, but that's also 20-year-old technology. And so it's not enough. You need to start implementing more things here. And then another common practice that I see that happens in the United States is a very, very, very small sample size. People will like to take this type of technology and they'll put it in a small vacuum and they'll try to assess, did this work on this small size? But the reality is that you're going to limit this, because if you only put a small sample of digital, you're not having the benefits of digital talking with every other platform here. It is just a small sample size. So you're not going to get the exponential gains of digital. You're going to see a couple of them, but that is not going to be a linear ROI when you're taking this to a senior management viewpoint. It is going to be just a snapshot of what you might be able to see in the future. But companies need to embrace this technology and ask themselves the question, is digital going to continue to come? Or are we going to go back in time and go back towards paper? Because I would assume that every single person here would agree that paper is an archaic tool, and there's really no purpose of it anymore in the modern world that we're living in. You can get cloud computing technology. We use what's called Angular JavaScript, and it is significantly nimble. It requires about 10–15% the bandwidth of a historical web application. So for companies that are in Mexico that have really poor Wi-Fi, or they have intermittent Wi-Fi, our system's able to be resilient enough to run on that. So the bandwidth consumptions of IT infrastructure, that's gone away. The cost of computing has gone way down. Cloud computing has gone down tremendously. And cloud computing is getting stronger and safer. The government, ITAR, just opened up an experimentation allowing for companies to start to move to cloud computing. It is just a paradigm shift in the way technology is going. And it's not a matter of, you just can't just keep waiting and waiting and waiting. You really got to get up and start moving on this.
I agree. This has been so good. Now we're out of our formal time, so I'm going to go ahead and stop the recording, but I hope that there's still questions. We got about 30 minutes to network and ask questions of our panelists, and just to be a little bit more informal. So I want to thank everybody who's been here, who has participated, and we're going to publish this so that it's available. And I thought the information, every time I thought, gosh, we should talk about this, you guys did. The conversation naturally went where I thought it should go. So thank you again, everybody. And if you'll stick around, we'll do some informal networking.